All right, so today we are talking about acceleration. Acceleration is just the rate of change in velocity per unit. So this is talking about when we think about acceleration, you're thinking about starting at a stoplight and accelerating to 60 miles per hour, or the car says it can get 0 to 60 in 4 seconds, or all that cool stuff. That's the cool stuff we think about with acceleration. Now, what really acceleration is just a change in rate of velocity. So this velocity meaning speed with direction. So any change in velocity per unit. We measure this in meters per second per second. So think about we measure speed in distance over time. We measure how we get to this particular instantaneous speed based on how fast we get there. So how much time it takes to get to that speed. So that's why it is meters per second or meters per second squared, because it takes we went a certain distance in a certain amount of time, and how long it took us to get to that calculation is basically what acceleration is. So acceleration due to the gravity of Earth is 9 meters per second, meaning that every second you increase your speed by 9.8 meters. So in other words, after 1 second, you go to 9.8 meters per second, then you're doubling it, then you're quadrupling it, and it keeps on going. You're multiplying more and more and more to create this large, huge amount of speed as you go. So falling towards Earth, you're increasing your speed exponentially. Uh, think about the speed how fast it takes to get down. The longest free fall is over 4 minutes long in the history of mankind. Uh, I'll post a video to a example of a skydiver who tried skydiving without a parachute into a net, and it shows how he reaches terminal velocity based on how the wind speed affects him, how airflow affects him, and how fast he is falling towards Earth. Now, acceleration is usually in kilometers per hour, meters per second, or kilometers per hour per second. So think about miles per hour per second would be how fast you can get from 0 miles an hour to 60 in 6 seconds. That would be your kilometers per hour per second that we're looking at. So what 3 ways can we accelerate an object? That would be increasing speed, like we always think of it, decreasing speed, and sometimes we call this deceleration, or it's just a negative acceleration, and change in direction, meaning that all we're changing is velocity, and velocity is just change of direction. So it's possible to have 2 different changes of velocity at once, because you're speeding up, taking your turning, or slowing down turning. So that's possible of 2 different accelerations. So think about calculation of this. So change in velocity over time that it takes to get that change of velocity. So basically we're taking our final velocity, subtracting our initial velocity, and the time it takes to get there. So final meaning that the final one that we're going to, initial meaning whatever we're going from, and then time that it takes to get there. So if we take Natalie's acceleration on her skateboard straight along a path for 2.5 seconds at 4, and she reaches 4 seconds. That means that we're taking 4.0, subtracting it from 0. So 4 minus 0 is 4. And then we're going to divide it by 2.5 seconds. So that will give us an answer of 1.6 meters per second squared, or 1.6 meters per second. Either one works. So you see how we get there? We just take our 4.0, subtract our our 0, and we divide it by 2.5. Now, find the average acceleration for a northbound train that slows down from 12 meters per second to 9.6 meters per second. So in this case, we're going to put the final velocity, which is 9.6 first. Then we will put 12. So 9.6 minus 12 is going to give us an answer of negative 2.4, and we're going to divide that by 8. or 0.8. So think about 8 goes into 24 3 times. So our answer will be negative 3 meters per second squared, or meters per second. Okay? Because if we are slowing down, it'll be negative. So a turtle is swimming in a straight line towards the shore and has a speed of 0.5 meters per second. After 4 seconds, its speed is 0.8 meters per second. So once again, we have a positive acceleration. So we will have a 0.8 minus 0.5 and then divide it by 4. So basically, we're going to have 0.3 meters per second divided by 4 seconds, and that'll give us an answer of 0.075 meters per second. Now, a car is traveling 22.4 meters per second and skids to a stop, so meaning it will go to zero in 2.55 seconds. Determine the average acceleration of the car. So we are taking our final, which is 0, subtracting 22.4. That gives us a negative 22.4, and we're going to divide that by 2.55. That answer, of course, is negative 8.78 meters per second. See, if we are going to a stop, we expect it to be negative. All right. Now, how can we tell if an object is speeding up or slowing down? Speeding up, we have a positive answer. Slowing down, we have a negative answer. Another way of looking at that is our final velocity will be more than our initial if we are positive, and it will be less than our initial if we are a slowing down. So if we're speeding up, it's going to be more. If you're slowing down, it's going to be less than your initial. All right, that is all for today. Well, we can do this last one. So what is your acceleration if your speeds stay the same? So same thing we do with math. 60 is your initial, 60 is your final in 8 seconds. But 60 minus 60 just gives us 0. So if there is no change in velocity, we do not have any acceleration. All right. Now that is all for today. Your assignment is page 29 or 29 or 30. Let me check. It is page 30 in your workbook. Remember to finish the other 2 assignments for this week, and this is all for the week. Remember, you have a quiz that is posted and is due by Friday at midnight. Have a wonderful day.